Okay, so this is a pretty standard problem. So I will just quickly explain the problem. So you're given a two by two grid, sorry, a matrix, a two-dimensional matrix, and it's called grid, and it contains only two values, that is characters, either one or zero. One indicating a landmass, zero indicating water, and you need to return an integer number where the number represents the number of islands. So in this case, as you can see, roughly, I would say here to here represents one island. Then this is included. That's why the answer is one. Over here, as you can see, there is one, two, and three, three islands. So the approach is pretty simple. If you can think of, you all you have to do is traversal. Breadth, whether it being a breadth first or a depth first is totally up to you, because essentially what you will be doing is you will be iterating through the matrix cell by cell, and you will do a BFS or a depth first traversal and marking the visited cells as zero so that you don't visit them again. And every time you encounter an island, you keep a counter variable. So you can have like a counter which will be initialized to zero, and you'll just return the count. So for now, I'm going to take a BFS based approach. So let's just quickly implement it. So I'm going to be iterating, as I mentioned, cell by cell. So an M into N kind of a nested loop structure. And I'm kind of new to Java, so bear with me if I do some kind of mistakes. But I think you would do something like this. So number of rows would be grid dot length, but let's just extract that. Yeah, since it's a array, you don't need to do a method, but let me just take a property I would say, and I mean calls is equal to grid of zero dot length. Let's just do a sanity check here. Mm, yeah, 0, 1, 2, 3, 4, and 1, 2, 3, 4, 5. Yeah, that's how you grab the rows and columns. Now let's iterate through the rows. Let's call it R, and then iterate through the columns. And if the grid is equal to, let's say, 1, then we will do, sorry, count plus equal to 1, and otherwise just return otherwise, and obviously do a traversal here. So this is where I will be doing the traversal logic. It's kind of up to you if you want to keep it as a separate function, but since Java does not support function side of function directly, I will do a breadth first search traversal right here. So here's going to be my BFS logic. So talking about BFS in matrix, all we are doing is We are visiting a cell, changing its value to 0, exploring its neighbors, and when we are exploring the neighbors, we are going to add them into a queue. So we'll need to implement a queue. So as far as I recall, you will to implement a queue, you can just call queue, and this would be a queue of coordinates. So a list of integers x comma y. That's it. And let's call it q is equal to how do I implement so this is going to be the interface, but I will need the implementation here. So it should be something like a new, I think linked list does it, but in this case I'm not too sure. So let's ask ChatGPT, I would say. Let's just quickly Google. I'm just asking GPT how to implement a queue of list of integers. So let's just do it. Implement a queue list of integers. So he's using an implementation called array deck. So we can use it, I guess. And another thing is for NQ operation, we call it offer. It's kind of weird. And DQ operation, we call it poll. And for getting the front element, just getting it, it's peak. And QMT is QMT. So as he mentioned, an array deck or array double-ended queue should be fine here. And uh, usually what I do instead of having multiple if else statements, I just iterate through a loop. So, and because that is one way of how you can explore the neighbors instead of having four statements that are very similar to each other. So let's just start with the BFS approach. So you will use this queue here. To be frank, we need to, this needs to be reinitialized every time we encounter an island. So q dot enq. So as they say, it's an offer is enq. So we will enq a list of integers, comma x comma y. So as far as I know, you can do something like new array list or name ports. I know I'm not doing it the best way, but let's just think about it later. Uh, Chords or add up, comma C. Uh, so, okay. So now this is being so many lines. Let's just try to fix it, please. Um, I think you can use something that as list thingy I just read today. So comment this and you will take a new array list of you're going to use arrays dot as list of you can just do this. Yeah, let's just see if it works. Ooh, it's blasting. Illegal start of the expression. Is it like this? Okay, makes sense. Hmm. So that's how we are going to add. Instead of having three lines, I can make this entire code super bulky. So you have appended. Now, while q dot is empty, while it is not empty, we want to keep doing the VFS algorithm. So what you will do is you want to append the neighbors. So first pop the coordinates. So chords is equal to, which is going to be list of integers. Chords is going to be q dot whole, right? Then you're going to get the x comma y through chords, and you're going to do like the neighbors. So you're going to have int nr comma int nr comma nc, and nr is equal to um so the idea is you want to get the neighbors, right? So I don't want to make it too complicated, so I will just do like int nr comma nc, nr is equal to chords dot get 0, nc is equal to chord get 1. So if we unpacking or something, then we could get we need to check now if um, if grid of nr, let's go up, is equal to 1, then append this to q, offer nr nc minus 1, and just copy this. Sorry, by repeating. Okay, 4 directions. This is up, this is down, this is left, this is right. Replicate here. Okay. So now if it is, then what we will do is, and here immediately we mark it as visited once we add to the queue. So r comma c becomes 0, and nr comma nc is equal to 1. So we will do the same thing here. Rate of nr minus 1 comma nc. And another thing is we will need to check if nr is greater than 0, and I think we can handle that case here. So if nr comma nc is equal to, we will find it to be 0. Okay. Similarly here, rate of nr nc nr plus 1 is equal to 0. The rate of nr nc minus 1 is equal to 0. And the rate of nr minus 1 nc equal to 0, right? Once you have that, we need to make sure that this doesn't go out of bounds. So we need to make sure that if you're going up, we need to make sure NR is greater than 0. And if you're going here, NR is less than the number of rows. And here, make sure NC is greater than 0. And NC is less than the number of rows. We need to make something of this. So let's see. Okay, now we have basically added the elements or the neighbors to the queue, and what we are going to do is, so how it is working is we have added this and then once we pop it, we are doing it here and we are getting the coordinates, and then we will append the neighbors, and we are doing it in a manual way. 1, 2, 3, 4. We'll go in all directions. 1, 2, 3, 4, and then add those, and then until the entire process is done, until the queue becomes empty, we will continue. And we are visiting only if it is 1. And yeah, I think it should be good. Let's try it quickly. Couple of syntaxes. Okay. Line 4. Yeah, this one. Index 4 out of bound. We did check, right, that if NR is less than rows, then only we will do this. I think it should be rows minus 1. And similarly, here it should be column minus 1, because let's say there are 4 columns, then your calls value, let's say if it is at 3, it shouldn't go to 4. So I guess it should be this. Yeah, should work pretty slow, given that we're not visiting again and again, but I'm not too sure. Let's just try to write this in a better way, actually, if that's fine. We will need to have a directions array, I would say. Let's keep something like a directions, uh, a list of integers. So a list of integers, no, a nested list, integers called directions, and then new array. We need to make this directions. No, array list of let's go up. Let's go next. It's perfect. Yeah, send check. Finish. Okay. It seems right. Now uh, we will comment the this much out. Then we will go like for list of feature or direction in trends. We will use the PR comma TC is equal to uh, PR is equal to zero directions. Sorry, there. One. Okay, and we will now iterate through the directions. We will now just check if new directions come up. C now is equal to R plus PR and C is equal to C plus DC. Now we will just check if, and first we need to just check that if math dot min of NR comma NC is greater than 0. Okay, and math dot we just NR is uh, less than both minus 1 and NC is less than equals minus 1 and uh, NR NC is equal to 1. Then what we will do is get off NR comma NC, mark it as visited by just doing this, and add to the queue. So new array list of we're essentially just doing NRNC, right? So yeah, now we're adding this, and all of this can go away. So if the minimum value is greater than 0, then that's fine. Okay, it shouldn't be negative, and this thing should be less than rows. This thing should be less than columns, not this is anyway updated. Anyway, how I could do. I think that's pretty much it. I can't do much here. Mhm. Yeah, let's call it like this. And C is already defined. You don't need it. Yeah, one initial thought impression is that it's doing more than what's required. So either has done this, okay, makes sense, and you get the current one. Then you iterate through the directions. Every direction you go, and you are getting the updated direction DRTC. You're getting the new one in RNC, and then getting it. Let us check. This is up. This is down. This is left. This is right. You're iterating if grid is equal to 1, increasing the count, marking it as visited. Then you start off by getting the coordinates. Coords. Yeah, you are doing this thing as a mistake. Still, that's weird. It's anyway, just oh, there you go. There. So you encounter a one, you increment the count, you initialize a queue, you add that element to the queue, mark it as visited so that it doesn't again. So then you start the queue, start from popping the element from the queue. You get what you have popped currently, CCCR, CR and CC, okay. And then you use CR and CC and get the next neighbors in RNC by iterating to the directions. And then you check if it is greater than 0, that's fine. That means it's valid. Or if the rows is less than this, or NC, this is then the columns, or grid is equal to 1, and this is equal to 1. Then and only then we will add it to the queue. Okay. And then we will mark it as visited, and then we return the count. Okay, so weird. Let's just start printing the queue and see how it behaves. Print. I will. So 0, 0 should at least initialize the right and left, right? Sorry, right and down. It's starting with that. Okay, no worries. Let's just see. But that shouldn't matter, right? 1, 0, 0, 0. At least next stage you need to append two values. I'm expecting at least here, not along with 0, comma 1, which is first row, second column, but I need at least 1, comma 0 as well, which is not happening. Why is it not happening? One comma zero should have been in the queue. This should append kind of stuck here. Let's just start printing LRN and see. Sorry. See, 1 0. Just check the condition again. This thing should be greater than 0. Yeah, it is greater than 0. You have printed 0 0, so you have printed the Q. So it's happening here. And then you check if its neighbors get printed or not. None of its neighbors are getting printed. Okay, 0 0. None of the neighbors are getting printed. That is a very weird state. It is not supposed to happen. Q root offer. CL 0, 0. It's fine. Then we start by exploring the neighbors. We check if math of name, if N and C represent the latest one, if their neighbors coordinates are greater than 0. If they are negative, then we can't do anything, right? Greater than or equal to 0. Check. Yeah, that was a big mistake on that. Yep. I think we ordered now. Let's just remove the print statement. Quickly. Right. Yep. BFS works. Don't think it's very optimal, but yeah, well, I lost ChatGPT. How we can improve it?